Okay, in this example, let's look at how to solve a system of equations by substitution. So here we have the system 5x plus y equals 22, 7x minus 4y equals 20. Now the first step in using the substitution method is to choose one of the equations and to choose one of the variables to solve for within that equation. Now it doesn't matter which equation you pick and which variable you solve for. So you want to pick the equation and variable that looks to be the easiest to work with. So in this case, we would choose the first equation and solve for y, since the coefficient on y is 1 in this equation, and it'll be easy to solve for y. So we'll take that first equation, 5x plus y equals 22, and to solve for y, we'll subtract 5x from both sides. So we'll get y equals 5x plus 22. Now here's where the substitution method comes in. We're going to substitute the expression negative 5x plus 22. Let's change that color to blue. So y is negative 5x plus 22. We're going to substitute that expression in the other equation for y. So here we have 7x minus 4y equals 20. So we're going to replace the y in the second equation by the expression that we just found for y using the first equation. So we'd get 7x minus 4 times the quantity, negative 5x plus 22 n quantity, equals 20. So we substituted that expression for y in the second equation. Now we have one equation that involves only x. We can solve this as we would do any linear equation. So we'll start by distributing to remove the grouping symbols. So we'll get 7x plus 20x minus 88. Now notice negative 4 times negative 5x will be positive 20x, and negative 4 times positive 22 is negative 88. So watch your signs when you distribute. We can collect like terms. 7x plus 20x is 27x. So we'll have 27x minus 88 equals 20. Then we'll add 88 to both sides. We add 88 to both sides, we'll get 27x equals 108. And then we'll divide both sides by 27. Let's go ahead and write that one out. 27x over 27 equals 108 over 27, which means that x will equal 4. Now that we know the value for x, we could go back to either original equation and solve for y. Now it's always a good idea to go back to the original equations in case you've made a mistake somewhere in between. Now if everything has been done correctly, you can go ahead and use the equation that you've solved for the other variable. So here we could use y equals negative 5x plus 22. And since we know that x is 4, we can write negative 5 times 4 plus 22. Negative 5 times 4 is negative 20, and plus 22 equals 2. So our ordered pair solution will be 4, 2. Now we'll want to check that in both the original equations. If x is 4, 5 times 4 is 20, and y is 2, so we get 20 plus 2, which is 22. 7 times 4 is 28, minus 4 times 2, it would be 28 minus 8, which is equal to 20. So the ordered pair 4, 2 satisfies both equations in the system, so it's the solution to the system. So we have a solution, it's the ordered pair 4, 2. And that's how we would solve a system using substitution.